Alright, so in this video I want to go over the Chapter 1 practice test for chemistry. Number 1, your answer should be D, that the tentative answer to a scientific question is a hypothesis. Number 2, experimentation involves the testing of variables. Remember, variables are the things that you change. Number 3, the most important rule in lab safety is to C, follow instructions. Even though A, B, and D are all definitely important for most labs, the instructions will tell you all those precautions, and they include them all. Number 4, an example of an SI base unit is the kilogram that measures mass. Number 5, an example of a derived quantity is area, A. The other 3 are all base or SI base units. Number 6, your answer should be D. Measurements are always uncertain because instruments aren't precise. That's true. Measurements involve some estimation. That's also true. But of course, we know C is false because people do know how to use instruments. Number 7 is C. A measurement that is very close to the standard accepted value is said to be accurate. Remember our discussion of accuracy and precision. Number 8, zeros are always considered significant digits when they occur between two non-zero numbers. B, when they function as placekeepers, they are not significant. Also, when they precede a decimal point, they're essentially a placekeeper. Those are not significant either. So looking on the next page to number 9, the unit of measure for density. The only one that has a mass per volume is C, grams per cubic centimeter. Number 10, how many significant digits are in the measurement of 0.005030? Well, since we have a decimal present, we want to start at the first non-digit 0 from the left here, and we're going to count 1, 2, 3, 4 significant figures. Remember, so that's answer B. Remember, if I'm choosing to write this 0 that I don't need, that's going to tell me it's significant. These are all placeholders. So number 11, the technique of dimensional analysis, it should say, is used to convert units of measurement C. Alright, so then we have the true and false, numbers 12 through 15. 12, the safety symbol showing a flame should remind you to secure all loose, instead of equipment, let's say hair or clothing. For number 13, it says the meter is the SI base unit for measuring length. That is true. For number 14, the metric prefix centi means 1/1000th or 0.001. That is false. 1/1000th from your conversion sheet, you should know that that is a milli for millimeter or milligram. Number 15, a vocabulary definition. A sensitive measuring instrument will give a consistent results under the same conditions. That should be precise instead of sensitive. Remember, you get the similar results over and over again. Even if they're not accurate, they can still be precise. So let's look at number 16. We've got 0.000000015 centimeters. We want to put that in scientific notation. We want to find where moving the decimal will give me a number between 1 and 10 all the way over to here, because if I go over 1 I get 15. So we're going to have 1.5 times 10 to the how many I moved over. So 1, 2, 3, 4, 5, 6, 7, 10 to the 8th power centimeters. Same idea for number 17, only we're going the other way. And by the way, that should be negative 8. So 1,360,000,000 grams. Now we have a positive exponent because we have a larger number. So we're going to have 1.36 because I moved this all the way to the left until I got a digit between 1 and 10 times 10 to the 9th as I moved over 1, 2, 3, 4, 5, 6, 7, 8, 9 digits. So those are my two answers for 16 and 17. Moving on to the calculation section. Number 18, we've got 6.15 meters times 3.026 meters times 0.018 meters. That should give you an answer in your calculator, something like 3349782 behind the decimal meters. And we're multiplying it by meters times meters, so it's going to be cubed. Our lowest number of significant figures is 3, or actually no, it's 2 in the third term. 0.018 only has 2. So we're going to write that as 0.33 cubic meters. Number 19, we have 1.6305 divided by 2.0. The bottom term, 2.0, only has 2 sig figs. So our answer, 0.81525 grams per meters cubed, should only have 2 sig figs. 0.8, and we'll round up the 2. Right, for number 20, you should see that 187.032 grams should have 6 sig figs because all zeros in the middle are included. Just count 1, 2, 3, 4, 5, 6. For 21, that's part A, sorry. Then part B should be 0.0601 cubic meters. We'll ignore the placeholding digits, zeros to the left. Start at the 6. We've got 3 sig figs. For part C, we've got 1.30 times 10 to the negative 12th. Remember, with scientific notation, we just include everything in this number here. That's going to be 3 sig figs. For part D, 620, this 0 is just a placeholder. So we're going to use 2. We're going to have 2 sig figs there. Alright, let's look at conversions. Number 21. Convert 160.57 grams into each of these units. For part A, we want kilograms. So we're wondering how many kilograms it is. We'll take 160.57. A good conversion unit for that would be 1 kilogram over 1,000 grams. Grams cancel out. 160 divided by 1,000 gives me 0.1657 kilograms. For part B, we want to go to micrograms, so same idea. 160, give our given value, take it times our conversion factor. There are 1 million micrograms in a gram. So let's put 1 million on top, grams on the bottom. They cancel out. We get a huge number, 160,570,000 micrograms. For part C, again, now we're just going to milligrams. So almost exactly like B, only we'll multiply by 1,000 instead of a million, because there's 1,000 milligrams in a gram. We get 160,570 milligrams. All right, let's look at some of the problems now. So for number 22, we're dealing with density. Density of iron is 7.86 grams per cubic centimeter. You're given the unknown metal that has a volume of 30.1 cubic centimeters. We know that density is mass per volume. So if we solve for mass, we can find that mass is density times volume. So 7.86 grams per centimeter cubed times 30.1 cubic centimeters. Those cancel out. We end up with a mass of 237 grams. So for number 23, calculate the number of feet in a 5-kilometer race. So this is going to involve some conversion. We know that an inch is 2.54 centimeters, and we know 12 inches are in a foot. So let's first take kilometers into something we know. You might not know offhand that how many kilometers are in a centimeter, or how many centimeters are in a kilometer, but you should know that there are 1,000 meters in a kilometer. And then that's going to tell me what it is in meters, and then I can take that times how many centimeters are in a meter. So there should be 100 centimeters in 1 meter. And then I'm going to go to inches, since I know that conversion factor. I'm going to take 2.54, 1 inch on top. So let's take 1 inch over 2.54 centimeters. Centimeters cancel out. Then finally, let's take 1 foot over 12 inches. Finally, take 5 times 1,000 times 100 divided by 2.54 divided by 12. You should get 1.64 times 10 to the 4th feet. So number 24 and 25, I'm going to briefly discuss those so I can get to the rest of the problems. Basically, as long as you pose a hypothesis, design an experiment to test your variables, and then evaluate your results. If you explain that, you're good. For number 25, a law of nature is something that you observe happening over and over in nature without contradiction. So if there's some way you can relate what you find in 24 to a law, you can say that. So let's look at number 26. We're trying to convert 8 hides into fardels, and we're given all those conversions. Let's just write it out. 8 hides. There are 4 yards in a hide, so let's cancel out hides. There are 4 nooks in a yard, so those all cancel out. There are 2 fardels in a nook, so let's cross nook out, and then if we multiply 8 by 4 by 4 by 2, we should get 256 fardels. Number 27 is a bit of a tricky one. They're saying if air is 21% oxygen by volume, oxygen has a density of 1.31 grams per liter. And we want to know the volume of a room that contains a mass of 80.0 kilograms. Notice immediately that density and mass are in different units. So let's convert this 80 kilograms to grams. We can move the decimal over 3 places. Or I'm sorry, 3 places in the other direction, because we're going to have more grams than we had kilograms. So small mistakes like that are reasons it's nice to write out your dimensional analysis. I'm just short on time. So we're going to have 80,000 grams. So I'm going to take, to get my volume, I'm going to take mass over density, 80,000 over 1.31. I'm going to get 61,069 liters. And then that's how many liters of oxygen I have. We know that oxygen makes up 20% of the volume, 21% of the volume of the room. So we want to figure out, this is 21% of what? So let's take 61,069 over 0.21. We're going to find that the volume of the entire room is 4.2 times 10 to the 30th liters. So I'm going to stop here, and part 2 will be next.